So the new section is 3.7, investigating graphs of polynomial functions. Basically, polynomial functions are classified by their degree, which we learned about the degrees in the last section. Talking about, like, if you remember, if we had an x to the fourth, it meant that there were 4 roots in the actual equation. So that's our degree. It's always going to be the highest exponent. The graphs of the polynomial functions are classified based on the degree of the polynomial. So an x to the fourth function always looks pretty much the same. It can be squished down or spread out. It could be flipped over, but it's always going to form the same basic shape. So each graph based on their degree has a distinctive shape and characteristics that go with it. The first function is a linear function. The first function is a linear function, and it has a degree of 1. So this would be a function that's like x to the first is our highest exponent, and it doesn't even matter what comes after that. It could be x plus 7,000, but it's always going to have the same form. Even if it's like 3x plus 4, it's always going to be a straight line, and it's either going to head upwards from left to right or downwards from left to right. But if our degree is 1, you know it's going to form a straight line. My next is a quadratic function. It has a degree of 2, and you'll notice that on my graph, the left side is going up and the right side is going up. That would be any equation that has an x squared as the highest exponent. Okay. Next is a cubic function that has a degree of 3, and that's any x to the third. Notice this one is on the left-hand side going downwards, and on the right-hand side going upwards. Next is a quartic function that has a degree of 4, and that would be any x to the fourth function, where 4 is the highest exponent. You'll notice that on the left-hand side it's going up, and on the right-hand side it's also going up. The last one is a quintic function. That's a degree of 5. This is my favorite type of function, because it has part of my first name in it. So on the left-hand side, you'll notice it's going down, and on the right-hand side, it's going up. And this would be an x to the fifth. end behavior is a description of the values of the function as x approaches infinity and as x approaches positive infinity, or as it approaches negative infinity. The degree in the leading coefficient of a polynomial determine its end behavior. So it's helpful whenever you're trying to graph a polynomial to know about the end behavior of the function. All you really need to write from this is right here in the center. Degree in leading coefficient determine its end behavior. This chart shows us exactly how we can figure this out. So if the function has a leading coefficient, a, that's greater than 0, so it has to be a positive number. Then if it's an odd degree, like x to the first, x to the, that should be a comma, not a 1. X to the first, x to the third, or x to the fifth. Those are all odd degrees because it's an odd number. Then as x goes to positive infinity, the function goes to positive infinity. So as my x heads further and further to the right, my function goes further and further up. As x heads to negative infinity, or goes further and further left, then my function goes further and further down. So that's how it works with odd degrees. With even degrees, as x goes to negative infinity, my function goes to positive infinity. So as x goes further this way, my y goes further up. And this would be like x squared, x to the fourth, x to the sixth, because those are all even numbers. As x heads to positive infinity, or as x goes further and further right, my y goes further and further up. If the function has a leading coefficient that's less than 0, or a negative number, then if it has an odd degree, as x goes to negative infinity, our function is going to be going to positive infinity. So the further back that x goes, the further up it goes. You'll notice it's basically the other function for odd degree flipped upside down. Same thing with as x approaches infinity, the function approaches negative infinity. For an even degree, as x approaches negative infinity, or goes further back, the y goes further down. And as x approaches positive infinity, or gets bigger, then the y also goes further down. So you'll notice with even degrees, they're always going to both endpoints are going to be pointing in the same direction. With odds, they'll always be pointed in opposite directions. All right, identify the leading coefficient, the degree, and the end behavior. So that p of x equals 2x to the fifth plus 3x squared minus 4x and minus 1. So for this first one, there should be a b here, letting you know it's a separate problem. For the first one, my leading coefficient is the coefficient that's in front of everything. So my leading coefficient is 2. Then I look at my degree. My degree for this one is 5. So you go with the highest exponent. Now, this is a positive number, and my degree is 5, so it's odd. So I can actually go back to my chart, and it will tell me exactly what my end behaviors look like. So if I look at my chart, my leading coefficient is bigger than 0 because it's positive 2, and it's an odd degree. So here are my end behaviors. As x approaches infinity, p of x approaches infinity. So as x approaches infinity, then p of x approaches infinity. As x approaches negative infinity, p of x approaches negative infinity. And that is literally all you have to do. Look at part B. My leading coefficient is a negative 3. My degree is 2. So it's an even degree with a negative coefficient. So again, I can go back to my chart. Negative coefficient, even degree. As x goes to negative infinity, p of x goes to negative infinity. And then as x goes to positive infinity, p of x still goes to negative infinity. On your homework tonight, this is exactly how I want to see it written. I want you to give me the LC, or the leading coefficient, the degree, and then our end behaviors written in this form. I have to